So our project is to determine the acceleration at different points of an elevator's motion through the forces that are acting on the elevator. We'll be using a scale, a constant mass, and the elevator at our local gym. Well, hello there! So our hypothesis is, if the elevator goes down, the acceleration will be greater than the negative acceleration when the elevator goes
As you
up.
can see, our starting weight is 33.5 pounds.
This is also Ashna's backpack.
Yay, Ashna! And now we begin our descent.
And now we start our ascent. Hi, Mr. Howard. We're doing the analysis now. Okay, so, everybody's blocked actually. So, basically, we have a backpack, right? That's really pretty. And then we have it on scale. At the scale. Pretty. And it's an elevator. And we have two forces on it. We have the force of gravity, and we have the force of motion. Fancy. Okay. So, we know the force of gravity because it was the original thing that was its weight when we put it in the elevator before the elevator started moving. And that was 33.5 kilograms, which is mass. Yeah. Something like that. And then we need to find the mass. So to find the mass, we're going to use net force equals mass times acceleration, because we can do that. Well, actually, no, we're going to use the force of gravity equals gravity times mass. That's what I meant to say. Okay. So we're going to use force of gravity equals mass times gravity. Okay. So we know that the force of gravity is 33.5 and that gravity is 3.8, which is, what am I trying to say? 0.8 mass divided by 9.8. And the mass is 3.42 kilograms. Fancy. Okay. So now we're going to do the 4 points of the acceleration. So the first point is right as we're taking off to go down. So we started in the second level of Jerry's. Now we're going to go down to the first. So basically, we're speeding up. Fancy. So we have our little backpack, and we have the force of normal and the force of gravity, just like that thing right there. So we know that the force of gravity. We know that the force of gravity is 33.5, and then the force of normal is basically what it jumps to. So in this case, it jumped from 33.5 down to 32. So that's our force of normal. Number one, or force of normal one. So the equation we're going to use is net force equals mass times acceleration to find acceleration. So we're going to do force of gravity because down is positive, minus force of normal 1, which is 32, equals mass times acceleration. So let's put that in there. That's an A. I promise. 33.5 minus 32 equals mass times acceleration, and mass is 3.42 times acceleration. So you just divide this by 3.42, and your acceleration 1 comes out to be 0.44 meters per second squared.
Ta-da!
Ta-da! Now we're going to do the second one, where we're slowing down. So we're slowing down to the first level. We have, again, our backpack and our fancy force of gravity and force of normal. Again, we already know force of gravity, so I'm not going to write it down. But this time for a force of normal, the scale jumped from 33.5 to 40. And that's our force of normal 2. So we're going to do the same thing, taking that equation. 3.5 minus 40 equals 3.42a. Divided by 3.42 divided by 3.42. A2 is negative 1.9 meters per second squared.
Since down is positive, this is
Yeah.
going up, technically. No, it's not.
Technically. It's going into the negative.
Yes.
Now we're going to do the third point. This is when we're taking off from the first level to get back up to the second level. So we're speeding up. We have our diagram. Force of gravity. Force of normal. This time, however, the force of normal was a bit weird. It kind of like flip-flopped. And instead of going down like it did for the first one, when it sped up, it went to 36.5, which is our force of normal 3. Now we're going to take 33.5 minus 36.5 equals 3.42a divided by 3.42 divided by 3.42. A is negative 0.88 meters per second squared. That's a third. And last but not least, they're getting like slanted. We have number 4, where we're slowing down at the top of the second level. Again, same free body diagram. Little box, we've got force of gravity, and we've got force of normal. For our force of normal, again, it kind of flip-flopped, and it went down instead of up. So it went from 33.5 to, once again, 32, which is our force of normal 4. So this is easy because we already did these calculations for number 1. Same numbers, 33.5 minus 32 equals 3.42a divided by 3.42 divided by 3.42. Cancel that. And A4 is, again, 0.44 meters per second squared. Ta-da!
Ta-da!
Hey, Mr. Howard, so the first acceleration that we experienced was. Why is my marker dying?
Is your marker dying?
Let's use a new one.
Surprise! We're gonna use a different marker quick. It's fine.
Ashna's fancy tiny little marker.
Oh, it's adorable.
It is adorable. Okay, so the magnitude and direction. So we had the components of force of gravity, force of why
Normal?
sorry
Okay, so it's the force of normal.
normal.
There we go.
Then, so at 1, since we started on the second level, second level. So that means that 1, we are speeding up. In the positive direction if we count down as positive. So, since this, so the magnitude of this, we had 33.5 was the original, and then we had to go to 32.
Yep,
and
and
the
our
reason why,
acceleration was 0.44.
yeah, and acceleration was 0.44. That's what we got for our end result. So then the magnitude is less than what the other ones were because we are working in the downwards direction because we're going down, as I said.
With gravity.
Yes, and we're going with gravity. So then force of normal has to do less work on the object. So therefore, that's why the acceleration, we do not have to do as much work. So for 2, we had to do the most work because we were working against gravity. because we were going technically up, and that's why we had an acceleration of negative, what was it? 1 point
Yeah, except there's a variation of it that's also really popular.
meters per second squared. So force of gravity, force of normal, and we are slowing. So we went from 33.5 to 40. So the acceleration or the force of normal had to do more work because it was working against gravity to be able to slow the elevator down, which is why the acceleration is greater. This goes over 3 as well because we are speeding up and we're going against gravity. Let me just draw this. So we are speeding up and we are working against gravity. So I will put that. We went from 33.5. We went to 36.5. And our acceleration was negative 0.88 meters per second squared. So even though it does not do as much work as this one, it still has to do more work to be able to speed up the object because it is working against gravity. And our fourth one, it was slowing down, and this one had the same components or the same acceleration.
Oh, sorry, she got 6 in
And it is also working, it's working with gravity because it's slowing down as, since downwards is positive, it has to slow down. So it has to work in this way, which is the same direction as the force of gravity.
Okay, the one that I think might be valid is
So then force of normal just overall has to do less work when the work is being done in the downwards direction, if we're calling downwards positive, since also force of gravity is working in the downwards direction. And if we have to work in the negative direction against gravity, then the work will have to be more.
It also should be noted that because number 2 is greater than number 3, that's because number 2 has the added work of going against the first acceleration, whereas number 3 starts from rest.
about nationals, how the winning duo was the 2 girls who are duo.
Acceleration. Perfect. And in the middle of the trip, the acceleration is 0 because our force of normal went back to equilibrium with force of gravity. So then, therefore, the force of normal does the exact same work as the force of gravity, and that is why the acceleration is 0. Yeah.
Monday.
How? What? Why? You are the best. You are the best.
We love you, Mr. Howard.
You are literally the best. Oh, bruh.
Yeah. He's apologizing. I am very sorry for the late change.
It's okay. We forgive you.
No, it's good. It's good. We forgive you.
See,
this is
okay,
amazing.
this week is about forgiveness.